Okay, class, we have section 3.1. We are beginning our study of rational expressions. So, not sure how long this goes with our new remote learning or where we get after this. We are not going to get as far as we wanted to when we had the end class with the topics after this, but we want to make sure we cover this topic. This topic is very important to your pre-calculus studies that will be coming up next. So, I know that there are a lot of things that are being canceled right now. But I want to let you know mathematically, if you see anything like this, no matter what gets canceled, we will never be canceling the x in this expression, okay? That is not something we do, okay? So one of the things you want to keep in mind when we look at rational expressions, these are things that can be represented as fractions. When you look at the bar that separates the numerator and the denominator, that bar groups the numerator and the denominator. If it helps you, when you see a fraction like this with expressions on the top and the bottom, it groups the numerator and the denominator. So I will not use expressions like things cancel out, okay? When I look at this x plus y and y, they are not equal. So I can't say that, I can't do anything to simplify that any further, okay? So that's what this is. Now if I saw something like, x plus 1, x plus 2 over x plus 1. So the fraction bar, it grouped the numerator and the denominator, okay? But everything you see is factors here. So when you look at x plus 1 over x plus 1, that is equal to 1, okay? So this evaluates just to x plus 2 being your answer, okay? So that's all free. That comes right before the lesson, but just keep that in mind as we go forward and take a look at things. So a rational expression is an algebraic expression in the form p of x over q of x, where p and q are polynomials. How fortunate is that? We just got through studying polynomials, and now we're going to have expressions where I have polynomials divided by polynomials. These are our rational expressions. So examples of rational expressions, all you see here are just what you see illustrated are just polynomials. In each case, a numerator and then a denominator. So these are all rational expressions, okay? Now, one thing we need to make in mind that, these are fractions. You're going to see fractional numbers that appear. And some of the skills that you had in reducing fractions, you're going to need those as well. So when I look at something like 24, so 24 divided by 36. Just like it is with polynomials, I need to figure out what are the factors. So what are the factors of 24? So if you don't know all of those, 24 can be divided by 2, and that gives me 12. I can divide that by 2, and I get a 6. Divide by 2, and I get a 3. So this is 2 cubed times 3. That's 24. And then what is 36? So 36 divided by 2, and you get 18. Divide that by 2, and you get 9. Divide that by 3, and you get 3. So this is 2 squared over 3 squared. So this is 24 over 36. So if you think about this, this is what you've got 2 times 2 times 2 times 3 over 2 times 2 times 3 times 3. So what you look at here is 2 divided by 2 is 1, 2 divided by 2 is 1, and so this is what I'm left with. Sorry, there's one more. 3 divided by 3 is also 1, so this answer just turns into 2/3. Okay. So again, what did we do? We factored the number into its prime factors, and then after we had it factored, then we were able to look and see if there was simplification. And again, I will not be using the terms cancel out. I would rather say 2 divided by 2 is 1 rather than canceling out, because one of the dangers is people get a little bit cancel happy when we start dealing with these rational expressions. Let's look at the next one. So now I've got multiplication that are going on. There are a couple ways I could do this. I could simplify each fraction and then do the multiplying. What we can do now, we could maybe just factor all the numerical values and then perform the multiplication and then consolidate. So if we think about this, what have we got? We've got 5 in the first expression. So I have 5, and then I've got what? X squared, y cubed, divided by 3 xy to the 4th times. So what is 27? Remember 27 is 3 cubed. So 3 cubed x to the 5th over 15, which is what? 3 times 5 x to the 4th y. So when you multiply, you multiply the numerators and the denominators. So I'm going to have what? 5 times 3 cubed. And then I have x squared times x to the 5th. That's going to be x to the 7th. And then I've got what? Y cubed divided by, what is it? 3 times 5. And then I'm going to have x. This was a x to the 4th right here. So I'm going to have x to the 5th and then y to the 5th. So if you think about, I've got 5 over 5, that is 1. And then I've got 2 3's in the bottom of the fraction, and then there are 3 of them in the top, so that just becomes a 3. So this becomes a 3. And then you've got what? X to the 7th, y cubed over x to the 5th, y to the 5th, and this becomes 3x squared over y squared. So some of this is what we did in earlier activities when we were dealing with exponents. Now, any exclusions? So when we talk about exclusions, to rational expressions, you want to look at your original, and you want to say, when would the denominator equal 0? So when does the denominator, I'm having a little bit of trouble with my stylus here. When would the denominator be 0 in that particular expression? So in that expression, I know that x cannot be 0 and y cannot be 0. Those are the two exclusions, because if I look at that original problem, if either of these conditions happen, I would be dividing by 0. So it's very important that you're looking at the original to get these answers. The final answer, when I look at the final answer, it was okay for x to be 0 because there were some simplifications that happened along the way. But my exclusions are that if I look at that original problem, under no condition can the denominator be equal to 0. So in any rational expression, when a variable represents the possibility of equaling 0, that is what we're going to call an exclusion. Now, when you get into calculus, you'll get a little bit more picky about the types of exclusions when you get into pre-calc. But for right now, identify where the denominator is 0, and that will be an exclusion for that expression. So if you look at the first one here, I know that x plus 1 cannot be 0. That means that x cannot be -1. That is an exclusion for that particular problem. Now the top of the fraction is 0, that's okay. It's the bottom cannot be 0, okay? If you look at the next one, I've got two conditions. In the next one, I know that x cannot be -1, and x also cannot be -2. So those are two conditions that would make the next expression equal to 0. Now in the next one, this is sort of a nice tie-in here, x squared minus 9. It's wonderful that we've just been factoring, because that is x minus 3, x plus 3. Neither of those can be 0. So x cannot be 3 or negative 3. If you go the last one, 1 over x, x cannot be 0. Those are the exclusions you see in those particular cases. I want to look at a couple of examples here. I've got a function that's f of x is x squared plus x over x plus 1, and then 1 over x plus 1. So let's look at these two examples. Factoring is going to be very key in simplifying these expressions. Look at that first one. The first one, you can factor the numerator into x times x plus 1 divided by x plus 1. So that is the expression. Now, if you think about it, what is x plus 1 divided by x plus 1? Well, that's just simply going to be 1. So if I look at that, that's going to evaluate to 1. So this function is going to behave like f of x equal to x. That's the equation of a straight line that goes through the origin, okay? But what are the exclusions? What are the exclusions? When you look at this thing, you know that x cannot be negative 1. So if I look at the graph of this particular example, when I graph it, I see the line, this is the line y equal x, but I know that x cannot be negative 1. So you see a hole in the graph at negative 1. So the domain of this function is from negative infinity up to negative 1, and then negative 1 to infinity. So that is the domain of this particular function. So for our purposes, this is an exclusion. When you get into pre-calculus, you're going to call it a removable exclusion, or a removable discontinuity, or a hole in the graph. You're going to have other situations. We're not going to deal with that now, so we're not going to be doing a lot of graphing in this particular unit. But what you need to be very comfortable with when you see this rational expression right here, you should key in on in a start that has a denominator that has a problem. It has a problem when x is negative 1. So we're going to call that our exclusion. Now let's go look at the next one. So if I take this one, same scenario here. I know that x cannot be negative 1. So this has an exclusion at negative 1. But the graph of this guy is sort of different. So if you look at this one, I'm graphing 1 over x. So when x is, or excuse me, 1 over x plus 1. So when x is 0, this becomes 1. When x is 1, this is 1/2. When x is 2, this is 1/3. When x is negative 1, this is undefined. Negative 2, negative 1. And so what you see here, you see the graph, and what we'll say here is that this line has what's called a vertical asymptote at negative 1. So if you think about it, the line cannot cross at negative 1. So this is a different kind of exclusion, but it's still an exclusion for the particular function. This one's called a vertical asymptote. So it is a place where the graph cannot cross that line. Again, this will be dealt with much more intensely in your pre-calculus class next year. What is the domain of this function? This has from negative infinity. The domain is from negative infinity to negative 1, cannot include negative 1, and then from negative 1 to infinity. So the point is, both of these functions have a problem, a discontinuity, and an exclusion at negative 1, but they appear differently. So that's just an intro to something you'll see more detailed in your class next year. It'll sound like I'm punting everything to your pre-calculus class today. So for purposes of this class, we're not going to categorize the different kinds of exclusions. So we're just going to look and say, what are the exclusions? They could be vertical asymptotes, they could be holes in the graph, they could be removable exclusion. We're not going to get in that detail. You need to be very comfortable just looking at any denominator and telling me where the exclusions are. Okay, and what you must do, you must make this determination before you do any simplification of this problem. So let's take a look at the first one. What I need to do in order to look at this expression and determine any exclusions, I need to be able to factor this completely. So if you look at the top of the fraction, I need two numbers that multiply to give me a 16 and add to give me a negative 8. Okay, so numbers that multiply to give me 16 and add to give me negative 8. That looks like a negative 4 and a negative 4 would do that. So this tells me that's going to be x minus 4 times x minus 4. So that is the numerator of that expression. Now, if I switch gears and look at the denominator, I need to do two numbers that multiply to negative 24 and add to 2. Okay, so that's probably going to be, was it 8, 3, 6, and 4? So it's going to be 6 and 4, with the 4 being negative. So those numbers multiply to negative 24 and add to 2. So this is going to be x plus 6, x minus 4. Okay. Now list the exclusions. The exclusions are where the denominator would be 0, undefined. So x cannot be negative 6 or positive 4. Then the next thing I want to do now, I want to go forward and simplify. So I've got x minus 4, x minus 4 over x plus 6, x minus 4. So you know that x minus 4 divided by x minus 4 is simply 1. So this turns into, this is x minus 4 over x plus 6. So that is the simplification of this particular rational expression, and I know my exclusions are x cannot be negative 6 and positive 4. Now here's the thing, if you were to wait to the very end to look for your exclusions, you're going to say x cannot be negative 6. You will miss that x could not also be 4. So you need to find your exclusions before you do your simplification. So let's look at another example. Simplify this expression and list any exclusions. Factoring is the key. Look at the numerator there. It looks like the greatest common factor is going to be 2x. So if I look at factoring this, I get 2x, and then I'm left with x plus 5. And then if I look at the bottom of that fraction, I need two numbers that multiply to give me a 15 and add to give me 16. And so those numbers are going to be 1 and 15. So that's going to be 3x squared plus x plus 15x plus 16. Then I factor by grouping. So this is going to be x, 3x plus 1 plus, and sorry, I made a typo here. That's not a 16 here, that's a 5. So then factor out a 5, 3x plus 1. So I'm left with x plus 5. X plus 1. So this is x plus 5, 3x plus 1. Now what are my exclusions? My exclusions are that the denominator cannot be 0. So that tells me that x cannot be negative 5 and it cannot be negative 1/3. So those are the exclusions. And now in order to simplify this, you're going to have, what do I have? 2x over x plus 5 divided by x plus 5 3x plus 1. So you know that x plus 5 over x plus 5 is 1. This simplifies to 2x over 3x plus 1. Perform the multiplication and simplify. List any exclusions. So again, the key to all of these problems is Are you remembering all of your factoring rules? Okay, so look at the very first one here. It looks like in first I can factor out a 5x. So I'm going to have 5x, and then I'm left with 4 minus x. On the bottom, that's going to be, I can factor out an x minus 1 times, if you look at the next expression, I need two numbers that multiply to negative 4 and add to 3. So those numbers would be what? Negative 1 and positive 4. So this becomes x minus 1 x plus 4. And then on the bottom, that's the difference of squares. That's x minus 4, x plus 4. Now, before I do any simplification, what are my exclusions? So my exclusions are where the denominator is 0. So x cannot be 0, 1, 4, or negative 4. So these are my exclusions. And now I look at simplification. I look at x minus 1 divided by x minus 1. I look at x over x, okay? And so that leaves me with 5 times 4 minus x. And then I also have what? There was a x plus 4 over x plus 4. So I got 5 times 4 minus x over x minus 4. Now there's also a little trick here. I could say, let's rewrite this as 5. What if I had to factor out a negative 1 here? So this is going to be x minus 4 over x minus 4. Because what happens when you multiply negative 1 times x minus 4, that gives you negative x plus 4, which is the same thing you see here. Okay. Now the reason I do that is because x minus 4 over x minus 4 is 1, so this answer turns out to be negative 5. Perform the multiplication and simplify. So again, factoring is going to be your key for all of these guys. So x, I've got x, oh, sorry about this, x minus 4. And I know you don't like this, but that is the sum of cubes. X plus 2 times x squared plus x squared minus 2x plus 4 times x squared minus 2x plus 4. Now, what are all the exclusions? The exclusions are where the denominator cannot be 0. So I know that x cannot be negative 2. Now, if I set that quadratic equal to 0, remember when we factor the sum or difference of cubes, the quadratic has no real solutions. It's only complex. So if I set x squared minus 2x plus 4 equals 0, this has no real solutions. And by it having no real solution, that means there are going to be no exclusions, no real numbers that are excluded. So this is my only exclusion. And x squared minus 2x plus 4 divided by x squared minus 2x plus 4, those simply divide out to be 1. So this answer is just x minus 4 over x plus 2. So that's your final answer. Now we have a division problem. I mean, people don't like division. Here's the thing. turn that into a multiplication problem as quick as you can. So let's just say this is going to be x squared minus 4x minus 21 over 5x plus 15. Let's turn this into a multiplication. So instead of dividing by that fraction, we multiply by its reciprocal. So just turn the division into a multiplication and now go through the same process we did a minute ago. So I need to factor. So if I look at that first expression, that's going to be x minus 7, x plus 3. That's just doing our method of two numbers that multiply to negative 21, add to negative 4. The next one, factor out of 5, x plus 3 times x squared minus 100. That is the difference of two perfect squares. X squared plus 3x minus 70. So numbers that multiply to negative 70 and add to give me a 3. So that's probably going to be a 10 and a 7, with the 7 being negative, okay? So this is going to be x plus 10, x minus 7. Now, before I do any simplification, what are my exclusions? So my exclusions, the denominator cannot be 0. So x cannot be negative 3, negative 10, and positive 7. Those are my exclusions. Now we look for simplification. X minus 7 divided by x minus 7 is 1. X plus 10 over x plus 10 is 1. X plus 3 over x plus 3 is 1. This final answer is just x minus 10 over 5. So here's my final answer, simplification, and you also see my exclusions that are listed there. Now the key was, remember I turned it into a multiplication. That's when I turn it into a multiplication, and then that's when I go looking for my exclusion. So rather than doing it from the very beginning with the division, because you're going to flip that fraction anyway. So let's look and see. I think there is one more before we're done with this. Yes, and you are almost there. So let's look at this. Perform this division. So this is going to be 3 x squared plus 13x minus 10 divided by 6x squared. And instead of dividing by 3x squared minus 2x, let's multiply by its reciprocal. So that's 3x squared minus 2x. And now we factor everything that we can. So we look at the first numerator. Are there two numbers that multiply to negative 10 and add to 13? So multiply to negative 10. Excuse me. I've got a problem there. They don't multiply to negative 10. They multiply to negative 30. So two numbers that multiply to negative 30 and add to positive 13. So that's going to be a 10 and a 3. Is that right? That is not going to do it. It looks like the numbers that I'm looking for will be what, a 2 and a 15. Those numbers multiply to 30, and if I had the 2 being negative, they would also then add to 13. So that becomes what, 3x squared minus 2x plus 15x and minus 10. So this, you factor this by grouping, and you have what, x, 3x minus 2 plus 5, 3x minus 2. So this is what, x plus 5 times 3x minus 2. So knowing your factoring is critical here. So this now becomes what? X plus 5 3x minus 2, and then you've got what, 6x squared times, if you factor out an x here, you get x times x minus 2. Now, what are my exclusions? Okay, my exclusions are all found in the conditions on the denominator. X cannot be 0 and x cannot be 2. So those are my exclusions. And now to get to my final answer, you know that, is there any simplification here? There is, wait, sorry. When I did this factorization, let me back up. When you factored out the x, you're left with 3x minus 2, so there's a 3 right there. So that is 3x minus 2. And so now you've got 3x minus 2 over 3x minus 2. That evaluates to 1. And then you're going to be left with x plus 5 divided by 6x cubed. So that is my final answer here, my final simplification. So again, everything in here, a lot of this is dealing with fractional simplification we did before, but the big key is denominators cannot be 0. So those represent your exclusions. You must be able to factor, and you can only, I'll use the word cancel here, cancel complete factors. The better way to think about it is this factor divided by this factor is 1 rather than canceling things out. Okay?